So next, I want to show you the deployment application wireframe. This is the second application or simulation. This would be less of a simulation. This is more of an application. So we had the device simulator for the purpose of helping to develop a deployment application. Now, I want to caveat this. I do not develop front-end applications. So, if you're a front-end developer, you may view some of this as, not very good practice. I would agree with that. What I'm highlighting here is some of the capabilities that you can do using the oneM2M ontology, and this is a demonstration application that accomplishes that. What I'm using here is, for this deployment application, I've developed a web browser-based application that will display a map, and also it'll have a drop-down list of devices, and it'll also indicate the latitude and longitude of a device or a place clicked on the map, and then also the ability to do an update. So what'll happen in this application is, whenever a new device is registered to the oneM2M CSE, that device will be entered into the device drop-down list. So that implies that we will have a subscription to CSE base, and we'll be capturing new AEs that are created at CSE base. And then that value will be placed into the device drop-down list. And then we can select one of those devices from that drop-down list. And when we select that device, we can go ahead and click on the map to specify the exact value where the device is located. And then once those two things are done, we hit the update. And when we press the update button, this will send a semantic descriptor, create semantic descriptor primitive to the CSE in order to add this semantic information to the device in the CSE. Next, I want to show some of the libraries that I'm using for these web applications that I'm creating. For the GUI interface, I'm using a Python library called Dash and Dash leaflets for plotting the maps. Also related to plotting the maps are Pandas and Plotly Express. Since my device is going to be sending primitives to the CSE, I'm using HTTP as the protocol and JSON for the serialization of the oneM2M primitives. So I have the request and JSON libraries also loaded. And then finally, I have a HTTP server that is running in the thread so that it can receive the notifications of new applications that are registering to the CSE. And again, the thread is necessary in a web application because there's threads running for the GUI component. So we need a separate thread for the HTTP server. So a couple points to highlight here, very similar to the, any application in oneM2M, you have to register a particular device or application, so the create AE occurs. And then also we want to subscribe to the CSE base to be notified of new devices registering so that we can place them in our, in our drop-down list. So in order to do that, we have to create our, do a create subscription primitive. And then whenever our update button is pushed and a location has been selected, we're going to do our create semantic descriptor primitive. Now, I'm only going to show here the code specific to the create semantic descriptor because that is the focus of this presentation, but you'll see all the other code in the demonstration, and also it'll be available on the oneM2M GitHub site or the GitLab site. So what we have here is the create semantic descriptor with location method or function in Python, and it's a very simple process here. What's happening is whenever we click on the map, this function will get called with the value from the device drop-down list and also the latitude and longitude that were selected on the map. And then what I've done was I've embedded the RDF triples into the code and placed the formatting and variable substitution in so that we can place the device name in the first space, and then also the latitude and longitude into the appropriate places of this particular semantic descriptor. And then also additional values that are being read from the config file are used to specify the URL that we'll be targeting. You'll notice that there are 4 fillers there. We're writing to the CSE IP address and port, and then also the CSE name and the AE resource name. The payload of the semantic descriptor is shown right above that. And what you'll see right before that is we take our descriptor string and we encode that into our base 64 format, and then that value is placed into the payload of our semantic descriptor representation. And then the primitive is sent. So what happens after that primitive is sent and comes back successfully, that device is removed from the drop-down list. So we'll continue doing that control until all the devices have been located on the map. And then that's it for the deployment application. And the idea there is when you have a device that you put into operation in the field, it'll start up. We want a way to configure it so the deployment app is specifying its location, and then once that's done, that deployment app is no longer needed. So what we're doing next is going over to the control application, and this is where an operator could monitor all the devices in a particular deployment. It can view the devices on the map, and it can control devices or see the sensor values all in a nice application and with a nice interface to that. What I'll be doing here, not quite 100% finished application, because I wanted to, this is more of a tutorial. So what I have here is the ability to enter a query and send a specific Sparkle query to the CSE to receive a response. In a real application, we would probably limit the amount of flexibility to these queries that are possible. But for this tutorial, this is a good way to highlight the capabilities that exist because of our semantic support in oneM2M. So the idea here is that you enter a Sparkle query into the query box and you press the query button in order to send a primitive. It's a request primitive, it's a semantic query primitive to the oneM2M CSE. The response will come back, and the idea is that this is going to return a series of devices and their locations, so that the map can be updated with the location of these devices. And then also, it's going to populate those device names into the device drop-down list. And then once you select a particular device from the drop-down list, what's going to happen is buttons are going to be exposed that show how to execute each of the operations for a particular device, or there will be some fields for the sensor values, if that's what the particular device does. So again, like all oneM2M devices, we have to register the device. So the control application does a create AE primitive. And then when the user types in to the query edit field and hits the submit button, that will translate to a semantic query request, a retrieve operation that is sent to the CSE, where the results are returned and then processed for when the service operation is selected. So this semantic query shown here is really just taking the value that is typed into the query box and doing the encoding of it and just sending a request query. The key things here are, that I want to highlight are we have two different parameters in the request here. We have our semantic filter, which is the SMF value. This is the encoded query that is being sent to the CSE. But then also there's the SQI parameters, the semantic query indicator parameter, and that defines whether this request is a discovery request, a semantic discovery request, or a semantic query request. And the difference between the two is if it's a semantic discovery request, just like in oneM2M discovery requests, the only thing that you will receive back is a URI, a list of URIs for the devices that match your particular query. If it's a semantic, if this is a semantic query, as opposed to a semantic discovery, then you get back more open-ended information. You get back information that represents and looks more like the query that you entered. So by using a semantic query indicator, I can specify that I want to receive more information from the semantic triples. For example, I want to receive the device identifier. I also want to receive the latitude and longitude from this query so that I could populate the information on the map with from the response that I get here. So that is it for the presentation of our deployment. My name is Bob Flynn, and I'm the founder of Exacta Global Smart Solutions, and I'm also the vice chair of the TDE working group in oneM2M. And you can feel free to reach out to me at any time.
And my name is Andrea Cimino. I'm a postdoctoral researcher at the Universidad Politécnica de Madrid. Feel free to write me on email with any doubt or question you could have, or you can contact me on LinkedIn using the link. Many thanks.
Next, we're going to see a demonstration of the semantic annotations that we've been talking about. I'll be using a oneM2M CSE provided by Cordant. The oneM2M CSE is the IoT platform that all the devices will communicate with. The sensors at the bottom here are what we've been talking about, describing with our ontology language, and we talked about when we would be sending the semantic descriptor resources into the to the CSE. So at the bottom, I had the 10 devices that we're talking about, and then they all register to the IoT platform. And like we described earlier, the deployment application has a subscription such that whenever a new device registers to the oneM2M CSE, it receives a notification so that the deployment application will, in the deployment application, we'll be able to specify the location that these devices were deployed at. And then the separate control application can be used to issue Sparkle queries to help us select and locate these devices in our deployment. And then also these Sparkle queries will use the oneM2M base ontology to provide for us information of how we can actually interface with these devices. So let's move on to the demonstration.